By 1954, Packard Motor Car Company was in serious financial trouble. The tragedy was not a lack of ideas. Packard had several groundbreaking technologies ready for the 1955 and 1956 model years. Unfortunately, all of them arrived too late. In 1954, Packard was still relying on an inline 8-cylinder engine, a design that was already considered outdated by that time. This would be the largest version of that engine Packard ever produced, displacing 359 cubic inches. In fact, it remains the largest inline 8-cylinder engine ever installed in an American passenger car. One notable innovation was the use of an aluminum cylinder head. Yes, an aluminum head on a flathead engine. However, Packard faced real challenges with this design. The aluminum heads were prone to warping, which made them less reliable than the cast-iron inline 8 engines Packard had built successfully for many years before. From a styling perspective, the 1954 Packard was beginning to look dated. While it was certainly a handsome car, it was not leading design trends in any meaningful way. That said, Packard had an impressive team during the 1950s. John DeLorean actually began his automotive career at Packard, before moving on to General Motors. Dick Teague served as Packard's chief designer before later continuing his career at American Motors Corporation. Packard was home to several individuals who would later become major figures in the automotive industry, along with many others whose contributions were equally important. In 1955, Packard introduced what would be the final cars that could truly be considered authentic Packards. Soon afterward, the company merged with Studebaker and began sharing platforms, resulting in what became known as the Packard-Baker models. The 1955 and 1956 Packards were technological achievements in many ways. I want to focus on just a few of the remarkable engineering features found in these cars. Packard's first overhead valve V8. Under the hood, Packard finally introduced its first overhead valve V8 engine in 1955. Early in development, engineers believed a smaller displacement engine would be the correct approach. However, as other manufacturers began increasing engine sizes, Packard decided to design a V8 with significant expansion potential. The engine featured a 5-inch bore spacing and was capable of growing to as much as 500 cubic inches. This approach closely mirrored later Cadillac big block engines, such as the 472 and 500 cubic inch engines introduced in 1968. The Packard V8 lineup included several displacements. The 320 cubic inch version was used in the lower-level Clipper models. The 352 cubic inch version powered the senior Packard line. In 1956, Packard introduced the 374 cubic inch V8, the largest engine Packard ever produced. This engine became standard in senior Packard models, while the Clipper line received the 352 cubic inch V8. All Packard V8 engines were equipped with either a 4-barrel carburetor or dual 4-barrel carburetors. The 374 cubic inch dual 4-barrel engine found in the Packard Caribbean produced 310 horsepower with a 10-to-1 compression ratio. That was serious power for the time, and it remains unfortunate that it arrived too late to save the company. One interesting detail is that Packard sold some of its V8 engines to American Motors for use in Nash and Hudson vehicles. In 1955, Packard supplied the 320 cubic inch engine from the Clipper line. Initially, Packard reduced the output slightly, down to approximately 208 horsepower from around 220 to 225 horsepower. When Nash and Hudson discovered this, they complained, and Packard ultimately restored full power. It is somewhat ironic that Packard sold its V8 engines while deliberately reducing their output so they would not outperform Packard's own models. This likely did little to strengthen Packard's relationship with American Motors at a time when Packard desperately needed cash. Another remarkable feature of these Packards was the Torsion Level Ride suspension system. Instead of coil springs, the system relied on 4 torsion bars, 2 of which were approximately 9 feet long. If you look closely at the layout, you can see a main torsion bar running from the front lower control arm back along the frame. There was a corresponding bar on the opposite side. In addition, there were shorter compensator torsion bars, one on each side, connected to a central compensator mechanism. Most cars of the era used 4 coil springs, or a combination of front coil springs and rear leaf springs. Very few, if any, American cars used 4 torsion bars in this manner. The reason it was called Torsion Level Ride was not only because torsion bars acted as the primary springs, but because they delivered immediate resistance as soon as they twisted. Unlike coil springs, which can have a slight delay before resisting compression, torsion bars respond instantly. This gave the Packard a smooth, controlled ride that was neither overly soft nor harsh. However, using relatively soft torsion bars meant that heavy loads, such as multiple passengers or cargo, could cause noticeable rear-end sag. To address this, Packard employed an electric compensator motor, similar in appearance to a large starter motor. This motor rotated the compensator torsion bars to level the rear of the vehicle when necessary. The system did not operate continuously. Instead, it activated after a delay of approximately 6 to 7 seconds. Once the system detected a difference in ride height, the motor engaged and adjusted the torsion bars to restore balance. This was not an active suspension system adjusting in real time while driving. The delay allowed Packard to maintain a soft ride while still compensating for changes in vehicle load. The motor drove an arm connected to the compensator bars, raising or lowering the rear of the car as needed. The same mechanism operated on both sides simultaneously to keep the vehicle level. For the mid-1950s, this was an extraordinary piece of engineering, and certainly not an inexpensive solution. The brake system disaster. Introduction of treadle-vac power brakes. Inside the car, the brake pedal is labeled treadle-vac power brakes. Power brakes were becoming common by 1955 and were offered as an option on Packard models, with manual brakes still available as standard. However, this system represents one of the most serious engineering mistakes Packard made during this period. The problem was not how the power brakes functioned, but where the components were located. Looking under the hood, the engine bay appears fairly typical. You can see the oil filter, oil bath air cleaner, generator, heater box, and battery. What you do not see on the firewall is the master cylinder or brake booster. Packard made the unusual decision to place both components beneath the floor, directly behind the brake pedal. To service the master cylinder, you first had to pull back the accelerator pedal, remove the carpet, and access a removable floor panel secured with multiple screws. The brake pedal itself was connected to a piston located at the rear of the pedal assembly. Removing it required disconnecting a clevis pin. Accessing the master cylinder from above was nearly impossible without removing additional components. Adding brake fluid was especially difficult, as the fill cap was partially obstructed by the steering column. There was no dipstick, filler tube, or easy access point. Even routine maintenance became a major challenge. This was a Bendix treadle-vac system, and while rebuilt units exist, servicing the system on these Packards remains unnecessarily complicated. Given the advanced engineering elsewhere on the car, this design decision is difficult to understand. These are just a few examples of the engineering brilliance and strange decisions found in the final Packards of 1955 and 1956. Sadly, the last vehicle to carry the Packard name was the 1958 Packard Hawk. It did not even use a Packard V8, instead relying on a Studebaker-derived engine. By that point, the merger had already taken its toll, and Studebaker lacked the resources to continue developing the Packard brand. The Packard Hawk was essentially a reworked Studebaker Golden Hawk with a distinctive front end, an unworthy ending for a brand with such a proud history. Packard represents the golden age of American automotive engineering, when innovation and quality were paramount. The 1955 and 1956 models show what Packard could have achieved if circumstances had been different. What do you think about these engineering innovations and odd design choices? Leave a comment and let me know. Thank you for watching.